In 1960, two men descended into a place no human had ever been. They sat inside a steel sphere the size of a small car. Outside, the pressure was building to levels that should have crushed them instantly. The windows were cracking under the load, and below them, still falling, was darkness so complete and so absolute that the word darkness feels inadequate to describe it. They reached the bottom of the Mariana Trench, nearly 11,000 meters below the surface of the Pacific Ocean, the deepest point on Earth. And when they looked out of the porthole at the seafloor, at a place that no light had ever touched, where pressure exceeded 1,000 times what exists at sea level, where the temperature hovered just above freezing, they saw something that stunned them into silence. A flatfish, swimming calmly, as if nothing about its situation was extraordinary. Life at the bottom of the world. In conditions that everything we understood about biology said should be impossible. That was 1960. And in the 60 years since, we have sent fewer than a dozen missions to those depths. We have mapped less than 20% of the Pacific Ocean floor in any meaningful detail. We have named and described perhaps a fraction of the species that live in its deepest regions. The Pacific Ocean is not just the largest body of water on Earth, it is the largest unexplored territory on Earth. And what it is hiding, what we know it contains, what we suspect it contains, and what we have no framework yet to even suspect, is the subject of this journey. In this video, I am going to take you to the places beneath the Pacific that no documentary has put together in a single narrative before. From the hydrothermal vent systems where life exists entirely without sunlight, powered by the heat of the Earth's interior in a way that rewrote our understanding of what life requires, to the sound, a specific recorded, documented sound detected deep in the Pacific in 1997 that was so powerful, so unlike anything previously cataloged, that the scientists who heard it did not have an explanation for it for years. To a zone of the Pacific so remote, so biologically empty, so completely isolated from the rest of the planet, that the closest human beings to any person standing at its center are not on Earth at all. They are orbiting above it in the International Space Station. But I need to tell you 3 things I found in the research for this video that permanently altered how I understand the ocean. The first, there are ecosystems at the bottom of the Pacific that have never received a single photon of sunlight and that have been operating continuously for potentially millions of years. The second, the Pacific Ocean contains a mountain, a single volcanic structure that is larger than any mountain range on the surface of the Earth. And the third, somewhere in the deep Pacific, right now, today, there are almost certainly species alive that we have never seen, never named and never described, because the environment they live in has been visited by humans fewer times than the surface of the moon. 3 impossibilities. 1. Ocean. Let's go down. The scale of what we do not know. Quick pause. I recently started this channel to take you to the world's most extraordinary and hidden places. We're still at the very beginning. So every subscriber really matters. If this kind of content helps you understand the world better, consider subscribing. It helps me keep exploring and bring you even more breathtaking destinations and make even better videos. Thanks. Now let's keep traveling together. Before we descend, I need to give you a number that reframes everything that follows. 80%. That is the proportion of the Pacific Ocean floor that remains unmapped in any meaningful resolution. Not unexplored in the casual sense, unmapped. We do not know the shape of it. We do not know where its mountains are, where its valleys run, where its canyons drop and its ridges rise. We have better maps of the surface of Mars than we have of the floor of the Pacific Ocean. The Pacific covers 165 million square kilometers. It is larger than all the continents combined. Its average depth is approximately 4,000 meters. Its deepest point, the Challenger, deep in the Mariana Trench, sits at nearly 11,000 meters below the surface. If you took Mount Everest and placed it at the bottom of the Challenger Deep, its summit would still be more than 2 kilometers underwater. The volume of the Pacific Ocean is approximately 710 million cubic kilometers. That number is so large, it is effectively meaningless to the human brain. So here is a different way to think about it. If you emptied every other ocean on Earth, the Atlantic, the Indian, the Arctic, the Southern, and poured them all into the Pacific would still not be full. This is the territory we are entering, not a body of water with a floor we have surveyed and cataloged and understood. A territory so vast, so deep, and so hostile to the instruments we use to understand things that the majority of it exists, right now, in a state of genuine scientific unknowing. And in that unknowing, based on the fraction we have seen, what we have found is extraordinary enough that the imagination of what remains unseen becomes almost too large to hold. The world that sunlight never built. At 200 meters below the surface of the Pacific, sunlight disappears. Not gradually, the way darkness falls at dusk. Abruptly. The physics of water absorption mean that beyond 200 meters, the photons that power every ecosystem on the surface of the Earth, every forest, every reef, every field, every food chain that begins with a plant converting light into energy, have been absorbed. They are gone. And for a long time, science assumed that life went with them. The reasoning seemed sound. Life requires energy. Energy at the surface comes from the sun. Without sunlight, photosynthesis cannot occur. Without photosynthesis, the base of the food chain does not exist. Without a base, the chain collapses. In 1977, a research team from the Woods Hole Oceanographic Institution sent a submersible called Alvin to explore the seafloor near the Galapagos Islands in the eastern Pacific. They were looking for geological features. Hydrothermal vents, places where seawater percolates down through cracks in the ocean floor, is heated by the magma below and returns to the ocean loaded with dissolved minerals. They found the vents. And around the vents, they found something that the scientific community was not prepared for. Life. Dense, abundant, thriving life. In complete darkness. At depths where the pressure is crushing and the ambient temperature of the surrounding water is near freezing. Around the vents themselves, where superheated water emerges at temperatures that can exceed 400 degrees Celsius, life had not merely survived. It had built entire ecosystems. Tube worms reaching 2 meters in length, their bodies anchored to the seafloor, their plumes filtering the vent water, clams the size of dinner plates, shrimp with no eyes, their other sensory systems so developed they can navigate and feed in total darkness. Crabs moving across surfaces covered in a white bacterial mat, so dense it looks like snow. And at the base of all of it, bacteria. Not photosynthetic bacteria converting sunlight to energy. Chemosynthetic bacteria converting the hydrogen sulfide and other chemicals pouring from the vents into organic energy. Building biological material from chemistry rather than light. Creating a food chain that the sun had no part in constructing and that the sun's disappearance could not destroy. This discovery, made on the floor of the Pacific Ocean in 1977, is one of the most significant scientific findings of the 20th century, because it did not simply describe a new ecosystem. It rewrote the definition of life. Before 1977, the scientific assumption was that life requires sunlight. After 1977, the question became, what does life actually require? And the answer, energy and chemistry, in some form, in some combination, opened a door that has not closed since. If life can exist at the bottom of the Pacific Ocean, powered entirely by the heat of the Earth's interior, with no sunlight, no surface connection, no dependence on the world above, then where else might life exist? On the icy moons of Jupiter, where liquid water oceans may exist beneath frozen surfaces. On the floor of subsurface oceans on Saturn's moon Enceladus, where hydrothermal activity has been detected. In places, in other words, that we had previously dismissed as lifeless. The Pacific Ocean floor did not just expand our map of where life exists on Earth. It expanded our map of where life might exist in the universe. The mountain that nobody talks about. In 2013, a team of oceanographers analyzing data from the Pacific seafloor confirmed something that, had it been on land, would have been one of the most famous geological features on Earth. Tamu Massif, a single volcanic structure sitting on the floor of the northwestern Pacific Ocean, approximately 1,600 kilometers east of Japan. Its summit sits approximately 1,980 meters below the surface. Its base covers an area of approximately 310,000 square kilometers. To put that in context, the largest volcanic structure previously known was Mauna Loa in Hawaii, which covers approximately 5,200 square kilometers. Tamu Massif is 60 times larger. It is larger than the entire British Isles. It is comparable in size to the state of New Mexico. It is the largest single volcanic structure ever identified on Earth, possibly the largest in the solar system. It formed approximately 145 million years ago, during the Jurassic period, when dinosaurs walked the land above it. It erupted in a single massive pulse of magma that spread outward from a central point across an area the size of a small country, building the sea floor into the vast rounded dome that it remains today. And it sits there, on the floor of the Pacific, in water so deep that no light reaches it, completely invisible from the surface, unknown to science until the data that described it was finally processed in the 21st century. If Tamu Massif were on land, if it rose above the surface rather than sitting below it, it would be the most prominent geographical feature on Earth. It would be visible from space as the defining landform of a continent. It would have been known, named, studied, and wondered about for as long as human beings have been capable of wonder. Instead, it sat on the floor of the Pacific Ocean for 145 million years without anyone knowing it was there. That is what the ocean hides. Not just creatures and sounds and mysteries of biology, geology at a scale that dwarfs everything we can see from the surface. The sound that had no explanation. In the summer of 1997, scientists monitoring a network of hydrophones, underwater microphones originally deployed by the United States Navy to track Soviet submarines during the Cold War, detected something in the Pacific Ocean, a sound. It was unlike anything in the catalog of previously recorded ocean sounds. It was extremely powerful enough to be detected simultaneously by sensors positioned more than 5,000 kilometers apart from each other. It was ultra-low frequency, below the threshold of human hearing, and its acoustic profile did not match any known source. It did not match known species of marine life. It did not match earthquake signatures. It did not match volcanic activity. It did not match underwater ice movement, which can produce sounds of considerable power. The scientists who detected it named it the Bloop. a name that simultaneously captures the mundane reality of how science works and the complete inadequacy of language to describe what was actually recorded. Because for a period of years, the bloop had no explanation. And in the absence of an explanation, the question that the scientific community could not entirely suppress, even as they publicly maintained appropriate skepticism, was this: could it be biological? Could something alive, something very large, something unknown, produce a sound of this power at this frequency in the depths of the Pacific? The eventual explanation, arrived at through years of additional analysis, was that the bloop was produced by the fracturing of large ice formations in the Antarctic, a process called icequake, which can produce extraordinarily powerful acoustic events. The sound traveled northward through the Pacific via the deep sound channel, a layer of water at a specific depth where the acoustic properties of the ocean allow sound to travel enormous distances with minimal energy loss. The explanation is scientifically satisfying, and it is almost certainly correct. But here is what the bloop leaves behind even after the explanation. The Pacific Ocean contains a layer, the deep sound channel, through which sounds can travel thousands of kilometers, through which the fracturing of ice in Antarctica can be heard in the Central Pacific, through which, in theory, any sufficiently powerful acoustic event anywhere in the ocean basin could propagate across the entire Pacific in hours. The ocean has an acoustic nervous system, a layer through which information, in the form of sound, moves continuously from every point of origin to every point of reception around the entire basin, and we have been listening to it for less than a century, with instruments that can detect only a fraction of the frequency range it carries, in a system so vast that the signals we have never recorded likely outnumber the ones we have by orders of magnitude. The bloop was explained, but the question it asked, what else is the Pacific saying that we do not yet have the instruments or the knowledge to hear, remains entirely open. The zone of nothing. Quick pause. I recently started this channel to take you to the world's most extraordinary and hidden places. We're still at the very beginning, so every subscriber really matters. If this kind of content helps you understand the world better, consider subscribing. It helps me keep exploring and bring you even more breathtaking destinations and make even better videos. Thanks. Now, let's keep traveling together. At the center of the South Pacific, there is a region of ocean that oceanographers call the South Pacific Gyre. It is approximately the size of the continental United States, and it is, in biological terms, almost empty. The gyre is a circular current system, water rotating slowly around a central point, driven by the Coriolis effect and the prevailing winds. And at the center of that rotation, the water is extraordinarily stable. Almost no mixing occurs between the surface and the depths below. Almost no nutrients rise from the seafloor to feed the surface waters. Almost no plankton grow. Almost no fish gather. The water is so clear, so blue, so biologically sparse that oceanographers have described it as an ocean desert, or more precisely, as the clearest natural water on Earth. Light penetrates to depths of several hundred meters without encountering enough biological material to scatter it significantly. The surface water absorbs almost no nutrients. Life struggles to maintain even minimal density. At the exact center of this gyre, a point in the ocean approximately equidistant from the nearest land in every direction, sits a location called Point Nemo, the oceanic pole of inaccessibility. Point Nemo is the most remote location on Earth. The nearest land in any direction is approximately 2,688 kilometers away, in 3 different directions simultaneously, each the closest landmass. The nearest inhabited land is considerably further. On most days, the closest human beings to a person standing at Point Nemo are not on land at all. They are aboard the International Space Station, orbiting above at an altitude of approximately 400 kilometers. Point Nemo has no strategic value. No resources, no fishery, no shipping lanes cross it, no weather stations occupy it, no country claims sovereignty over it. It sits in the middle of the South Pacific Gyre, in the middle of the biological desert, in the middle of nothing, a point defined entirely by its distance from everything else. And humanity has chosen it, for precisely that reason, as the place to bury its most complex machines. Since the 1970s, space agencies around the world have been deliberately crashing decommissioned spacecraft, space stations, and satellites into the waters around Point Nemo. It is called the Spacecraft Cemetery. Hundreds of objects, including portions of the Soviet Mir space station, numerous Progress cargo spacecraft, and eventually planned segments of the International Space Station itself, have been or will be guided to their final resting place in the waters around Point Nemo. The reasoning is straightforward. Point Nemo is the location on Earth where falling debris is least likely to encounter human beings, ships, or inhabited coastlines. The ocean floor beneath it receives the wreckage of human civilization's greatest technological achievements in water so deep and so remote that no recovery mission will ever be attempted. On the floor of the Pacific, at the most remote point on Earth, surrounded by the biological desert of the South Pacific Gyre, lies a graveyard of human achievement, undisturbed, in the dark, in the cold, in the nothing. The ring of creation and destruction. The Pacific Ocean is enclosed on almost every side by the most geologically active boundary on Earth, the Ring of Fire. A horseshoe-shaped zone stretching approximately 40,000 kilometers from the southern tip of South America northward along the western coast of the Americas, across the Aleutian Islands of Alaska, south through Japan, the Philippines, Indonesia, and down to New Zealand. It accounts for approximately 75% of the world's active volcanoes and approximately 90% of the world's earthquakes. The Ring of Fire exists because of the Pacific Plate, the largest tectonic plate on Earth, covering approximately 103 million square kilometers of the Pacific Ocean floor. The Pacific Plate is old, dense, heavy, and it is moving, sliding beneath the lighter continental and oceanic plates that surround it in a process called subduction. Where the Pacific Plate dives beneath another plate, the friction generates heat. The heat melts rock. The molten rock finds pathways upward through the crust. And at the surface, or on the seafloor, it emerges as volcanic activity. Subduction is not a gentle process. The descent of one plate beneath another generates stresses that accumulate over decades or centuries and release in moments of violent seismic energy. The 2011 Tohoku earthquake off the coast of Japan, magnitude 9.0, the fourth most powerful earthquake ever recorded, occurred when the Pacific Plate lurched downward beneath the North American Plate along a boundary segment that had been locked for approximately 800 years. The energy released in the earthquake displaced the seafloor by several meters over an area of approximately 500 kilometers. The resulting tsunami reached heights of 40 meters in some coastal locations and traveled across the entire Pacific basin. But subduction also creates the volcanoes of Japan, the Philippines, Indonesia, and the Western Pacific Islands are all products of the same process that generates the earthquakes. As the Pacific Plate descends and melts, the magma it produces rises through the overlying plate to form island arcs, chains of volcanic islands that mark the line of subduction at the surface. Hawaii, one of the most geologically distinctive places on Earth, is a product of a different volcanic mechanism, a hotspot, a fixed point of anomalously hot mantle material that the Pacific Plate has been moving over for approximately 80 million years, producing a chain of volcanic islands that stretches 6,000 kilometers across the Pacific. The oldest islands in the chain, now submerged seamounts called the Emperor Seamounts, are in the northwestern Pacific. The youngest, the Big Island of Hawaii, sits directly over the hotspot today, still erupting, still growing, still being built from the same mantle plume that produced its predecessors. The Pacific Ocean is not a stable body of water sitting in a fixed basin. It is a dynamic, moving, actively reshaping geological system. The floor is being created at spreading centers and destroyed at subduction zones. The islands are being built by volcanoes and eroded by waves. The coastlines surrounding it are being compressed, uplifted, and reshaped by collisions that have been ongoing for hundreds of millions of years. The Pacific is not a feature of the Earth. It is a process. The creatures that light built. Below 200 meters in the twilight zone of the Pacific, the mesopelagic zone, where the last traces of sunlight fade to nothing, evolution has produced solutions to the problem of living in darkness that no human engineer would have conceived. Bioluminescence, the ability to produce light through chemical reactions within the body, not reflected light, not stored light, generated light, produced on demand, controlled by the organism that creates it. Approximately 76% of deep-sea species in the mesopelagic zone are estimated to be bioluminescent. 76%. In an environment defined by the total absence of external light, the majority of its inhabitants have independently evolved the ability to make their own. The mechanisms vary. Some species, like certain species of dinoflagellate, a single-celled organism, produce flashes of blue light when disturbed, creating the phenomenon of bioluminescent waves seen occasionally at tropical beaches. Some species of fish carry light organs called photophores along their undersides, producing downwelling light that matches the faint surface glow above them, making them effectively invisible from below to predators looking upward. Some squid species can control the pattern of their bioluminescent displays with a precision that suggests communication, flashing in sequences that appear to convey information between individuals. The anglerfish, perhaps the most immediately recognizable of the deep-sea species, uses bioluminescence as a lure. A modified spine on the top of the head carries a light-producing organ filled with bioluminescent bacteria. In total darkness, the anglerfish dangles this light in front of its enormous jaws, waiting for any creature attracted by the glow to come close enough to be captured. It does not chase. It does not search. It waits, with infinite patience, in infinite darkness, until the light does the work. But the most extraordinary use of bioluminescence in the Pacific Deep may be the dragonfish, a species that has evolved to produce not only blue-green bioluminescence, the wavelength that most deep-sea species can detect, but also red light. At depth, red light does not exist. It is absorbed at the surface. No species in the deep ocean is believed to have evolved the ability to see it, with one exception: the dragonfish itself. The dragonfish produces red bioluminescent light that it can see, but that its prey cannot. It navigates and hunts using a wavelength of light that is, for all practical purposes, invisible to everything around it. It has evolved a private spectrum, a secret light that belongs only to itself, in a darkness that belongs to no one. The garbage we cannot see. There is something else the Pacific is hiding. And unlike the hydrothermal vents and the bioluminescent creatures and the acoustic signals from the deep, this is something we put there. In the central North Pacific, between Hawaii and California, the interaction of the North Pacific subtropical gyre, a circular current system similar in structure to the South Pacific gyre, has been accumulating something for approximately 70 years: plastic. Since the mass production of plastic began in the mid-20th century, a proportion of the plastic waste generated by human civilization has found its way into the Pacific Ocean. Carried by rivers, blown from coastal areas, lost from ships, discarded at sea. Once in the ocean, it is carried by surface currents into the gyres, the circular current systems where water moves inward toward a slow-rotating center. And there, it accumulates. The Great Pacific Garbage Patch is not, as it is sometimes depicted, a solid island of plastic floating on the surface. It is a zone, approximately 1.6 million square kilometers, where the concentration of plastic particles in the water column is measurably elevated above background levels. Some of that plastic is visible: bottles, fishing nets, foam packaging. Most of it is not. Most of it is microplastic, fragments produced by the physical and chemical breakdown of larger plastic items by sunlight, wave action, and biological activity. Particles smaller than 5 millimeters, invisible to the eye, suspended throughout the water column. Marine biologists studying the Great Pacific Garbage Patch have found that the microplastic particles interact with the food chain at its lowest levels. Plankton, the microscopic organisms that form the base of the Pacific food chain, ingest microplastic particles. Filter feeders ingest the plankton. Fish ingest the filter feeders. The plastic moves upward through the chain, and at the top of the chain, in the tissues of tuna, in the flesh of swordfish, in the bodies of seabirds, it arrives. We put it in the ocean. The ocean has been returning it to us through the food we eat from it. The Pacific does not distinguish between what belongs to it and what does not. It incorporates everything that enters it into its systems, including us. The trench and what lives there. The Mariana Trench stretches approximately 2,550 kilometers across the floor of the western Pacific Ocean. Its average depth is approximately 8,000 meters. Its deepest point, the Challenger Deep, sits at approximately 10,935 meters below sea level, though precise measurements continue to be refined as instrumentation improves. To descend to the Challenger Deep in a submersible takes approximately 4 hours. The pressure at that depth is approximately 1,086 times atmospheric pressure at sea level. The temperature of the water is approximately 1 to 4 degrees Celsius. There is no light. There is no current of significance. There is almost no food. The organic material that drifts down from the surface takes so long to reach these depths that it arrives in a state of such advanced decomposition that its caloric content is minimal. And yet, as those first explorers discovered in 1960, and as every subsequent mission has confirmed, the Challenger Deep is not empty. Amphipods, small crustaceans, relatives of the beach hoppers found in the sand of any temperate coastline, exist at the Challenger Deep in populations dense enough to attract any bait deployed there. They are adapted to the pressure in ways that their shallow water relatives are not. Their cell membranes contain different molecular compositions that remain fluid at pressures that would solidify the membranes of surface species. Foraminifera, single-celled organisms that build shells from calcium carbonate or sediment particles, live in the sediment of the Challenger Deep. The sediment itself, sampled by robotic instruments, contains a rich microbial community. Bacteria that metabolize the scarce organic material drifting down from above. Archaea, a domain of life distinct from both bacteria and the organisms we typically think of as complex life. Present in numbers that suggest the deep-sea sediment microbiome is one of the most extensive on Earth. And when explorers reach the bottom, as a handful of humans have now done in missions separated by decades, they find tracks, marks in the sediment left by organisms that moved across the floor, burrows, disturbances, evidence of life in motion in the deepest, darkest, most pressurized, most isolated environment on the surface of the Earth. We do not know what made all of those tracks. We have not seen all of those organisms. We have not named them. We have not described them. We have not understood them. They are there, in the dark, making their marks in the sediment, waiting, though they do not know they are waiting, to be found. The Pacific that is changing. Quick pause. I recently started this channel to take you to the world's most extraordinary and hidden places. We're still at the very beginning, so every subscriber really matters. If this kind of content helps you understand the world better, consider subscribing. It helps me keep exploring and bring you even more breathtaking destinations and make even better videos. Thanks. Now, let's keep traveling together. The Pacific Ocean absorbs approximately 30% of the carbon dioxide that human civilization releases into the atmosphere every year. It absorbs it through a chemical reaction that has been occurring since carbon dioxide first existed in the atmosphere. CO2 dissolving into seawater, reacting with water molecules to form carbonic acid, which then dissociates into bicarbonate and hydrogen ions. The hydrogen ions lower the pH of the water. The ocean becomes more acidic. Since the Industrial Revolution, the average pH of the surface Pacific has decreased by approximately 0.1 units on the pH scale. That sounds small. The pH scale is logarithmic. A change of 0.1 represents approximately a 26% increase in acidity. For organisms that build shells or skeletons from calcium carbonate, corals, mollusks, certain species of plankton, increasing acidity means increasing difficulty in maintaining those structures. The same chemistry that dissolves calcium carbonate in acidic conditions dissolves the shells and skeletons of the organisms that depend on them. Coral reefs, the most biodiverse marine ecosystems on Earth, covering less than 1% of the ocean floor, but supporting approximately 25% of all marine species, are under pressure simultaneously from warming temperatures, which cause bleaching, and from acidification, which impairs their ability to rebuild after bleaching events. The Great Barrier Reef, though technically in the Coral Sea adjacent to the Pacific, has experienced 4 mass bleaching events since 2016, each one more severe than the last, each one affecting a greater percentage of the reef structure, each one driven by water temperatures that exceed the thermal tolerance of the symbiotic algae that live within coral tissue and provide the corals with the majority of their energy. Without those algae, the coral bleaches, turns white, expels the algae, and begins to starve. If temperatures return to normal quickly enough, the algae return, the coral recovers. If they do not, if the heat persists long enough, the coral dies, and the reef structure it built, which provides habitat for thousands of species, begins to erode. The Pacific is not simply responding to climate change, it is absorbing it, taking the heat and the carbon that would otherwise remain in the atmosphere and incorporating them into its chemistry, its temperature, its biological systems. It is buffering the atmosphere at a cost to itself that we are only beginning to measure. The ocean has been doing this for us without our asking, without our understanding. And now that we understand what it is doing, the question is whether we will change what we are asking of it. The return to the surface. 165 million square kilometers. After everything we have descended through in this journey, the hydrothermal vents where life rewrote its own definition, the volcanic mountain that dwarfs every surface feature on Earth, the acoustic signals that traveled 5,000 kilometers through the deep sound channel, the garbage we placed in a gyre that has been returning it to us through our food, the creatures in the darkness making their marks in sediment at the bottom of the world, that number still does not capture what the Pacific is. Because the Pacific is not a measurement, it is not a depth or a surface area or a volume of water. It is the largest continuous system on the surface of the Earth, the largest zone of biological activity, the largest geological processor, the largest carbon sink, the largest unknown, and it is changing. Right now, at a rate that is faster than anything in its geological history since the asteroid impact that ended the Cretaceous period. The chemistry is shifting, the temperature is rising, the ice at its northern and southern margins is retreating. The species distributions within it are moving toward the poles. The coral systems that have taken thousands of years to build are bleaching in weeks. The Pacific is not hiding from us. We have simply not been paying the kind of attention that something of this magnitude deserves. We have been traveling across its surface for 500 years without understanding what surface means in the context of an ocean 11 kilometers deep. We have been fishing its waters without understanding the systems those fish are part of. We have been depositing our waste into it without understanding where waste goes in a system this large. What lies beneath the Pacific is not a mystery to be solved and set aside. It is a reality to be understood and responded to, an 11,000-meter column of water, of life, of chemistry, of geological force, operating according to rules that we have been decoding for less than a century, in a system that has been operating for more than 3 billion years. We have barely begun to listen. But here is what I have not shown you yet. The communities that live on and around the Pacific, the island cultures of Polynesia, Melanesia, and Micronesia, have been reading this ocean for thousands of years. Not with hydrophones and submersibles and satellite altimeters, with their bodies, with the feel of swells against the hull of a canoe, with the behavior of stars reflected in the water, with knowledge of current patterns and wind systems and biological indicators that allowed them to navigate the largest ocean on Earth without instruments, in vessels made from wood and plant fiber, and to find islands the size of points on a map in the middle of more water than the human mind can contain. In the next video, we go to find that knowledge and what those navigators understood about the Pacific and what it understood about them in return will change how you hear everything you heard in this one. Tell me in the comments, which moment in this descent changed something in how you understand the ocean? Because for me, it is still the flatfish. Calm. At the bottom of the world. In conditions that should have made it impossible. Impossible, it turns out, is just a word we use before we look closely enough. Stay with us. The next journey goes deeper still. If you're enjoying this video, hit that like button, drop a comment with your thoughts, share it with someone who needs to see this. And if you're not subscribed yet, you know what to do.